Our third speaker is Professor Xinguo. He is the Dean of CCNU Wollongong Joint Institute and Professor of Central China Normal University. He's also a senior member of both IEEE and ACM, Vice Director of Smart Educational Technology Branch Society under the Automation Society in China, and also Chair of Hubei Society of Artificial Intelligence in Research and Education. Professor Yu is Associate Editor of International Journal of Digital Crime and Forensics. He was General Chair and Program Chairs for more than 10 international conferences. The talk today is Introduction to Research in Intelligent Education. Professor Yu, thank you.
Thank you for your introduction. My talk is Introduction to Research in Intelligent Education. Okay. This is the four aspects where we talk. Okay. So I will talk about the ground challenge on the education. Okay. The ground challenge is one kind of research. The topic like this, that is the very huge umbrella project. They have a lot of the research contents to form a grand challenge. It's like this. A simple grand challenge in computer science is P equal to NP or lot. Okay, they have a lot of research, and we have a grand challenge in the engineering on education. Give you concrete. What is the P vs the NP problem? Informally, this problem is asked for any problems. If a given solution can be effectively verified, can we find an effective way to solve by a compute? That is, okay, different version. Quickly verify the answer and quickly find the answer. This is two problems. Whether these two problems is the equal in computer in algorithms, that is the NP. P equal to NP or lot problems. This is one kind of explanation. Of course, we have the formal definition. Example, this kind of problem, they have example NP hard problem is, does a subset of given the series, a set of the numbers, whether they can sum to 0. This is easy since we just sum up, okay, whether there is 0. But we can change it to, we give you a very long series of the integers, whether you can select some of them, okay, maybe it's a fixed length, fixed number of the integers. How in the polynomial time you can find the subset can be summarized to 0 or not. Okay, that is the very hard. Okay, so what is the ground challenge? They have a standard. Nowadays, they have listed 13 conditions. This is the condition. We will not explain this the condition by detail. We just show you how to define the ground challenge. In the NAE, there is the organization, National Academic Engineering of Engineering, NAE. They have listed 14 great challenges for engineering in 21 centuries. Okay, this is the 14 grand challenge. In this the 14 grand challenges, they have 2 of them related with the education. The first one is the advanced personalized learning. Okay, advanced personalized learning means whether we can build up our systems can provide the advanced personalized learning to all the learners. Okay, this is a challenge, is a ground challenge. So although we have a lot of the paper talk about the personalized learning, but we don't have this kind of system, okay, yet. Okay, this is a ground challenge. if we want to build this kind of advanced personalized learning systems, we need a lot of things, okay, like modeling of our knowledge, modeling of our brain, modeling our learning process, and how is the learning process, how to evaluate of the learning outcome. All these things we need to solve. Okay. Another grand challenge related with education is reverse engineering the brain, because we need to understand our education, our learning outcome in our brains. We need to model our brains. How our brains is not educated brain became our educated brains. This is difficult, challenged problems. Okay. So, but nowadays we don't have the answer to this the challenge, grand challenges. But we cannot directly solve this grand challenge. Okay. But we are to do research on some sub-problems to accumulate knowledge little by little, and finally to build up to solve this grand challenge. Okay, this is the way. So, in the reality, we do the research on the intelligent education to identify some of the sub-problems to do that. What is the mission of the research on education technology? We have two things. One thing is we want to innovate the technology and then innovate the knowledge, the technology from other areas. Then we to build up, okay, then advance the education, means the intelligentization, then the education, okay. This one, in this way, we can enhance two areas. We have enhanced the education level, education, the reform the education, the way, okay. Also push the industry of educational technology. Okay. So how the technology, especially AI technology, reform our education. In order to answer these questions, we need to model our education. We propose then 5-letter model to describe our education. The 5-letter model is in this slides. The figure of this slides, the 5 letters, okay. Okay, in the list, okay. In the list figure, we have the 5 letter Z, S, P, K, L. Okay. Then Z is represent the privatization of education, because we think it's an atomic education process, include the privatization and the education process itself, education event itself. Okay. So privatization is one aspect of the education process. A lot of things in this education process, the most important things is the space, where all the education happen in a specified space. Okay, in the education, in the process of education, they will have the provider, education provider, and learner. This is two main roles in the education. All the space and the privatization, all these things is to enhance the efficiency of education. So we have this 5-letter model to describe atomic process of the education. Okay, so then we are study how our AI education to change this 5-letter. This 5-letter represent the 5 aspects of education. That is our understanding. AI technology, we think they are the represent of the AI technologies are A, B, C, D. A is the artificial intelligence, B is blockchain, C is cloud, D is data. Okay. The role of the AI in the education. Okay, the AI is A. Okay, we just short as A. Artificial intelligence, they have a lot of them things can do for our education. First one is can fulfill the educational routine job. Okay, they can do some of the repeat intelligent job and enhance the intelligence of education surface. Expand the educational space by creating virtual space. All these things can do is artificial intelligence. Of course, this is just some, with not the full list. We have list, we can list more. Okay. The blockchain is the enhance the security of the education contents by reliable field. Okay, because it's the education provided by our intellect is a bigger thing is how their contents is safe, especially for pupil. Okay. Then a lot of things, privacy protection on education. Okay. Because the intellect, we can build a lot of the monitor sensors, collect a lot of the data from the learners. Then in this way, the disclosure, then privacy of the learners, then we need to solve these problems, okay, by use the blockchain. Third things, the blockchain can help to copyright protection of the digital contents. And see what is the role of the cloud in intelligent education. Cloud is an infrastructure for transmitting the digital education contents. So with the educational cloud, all the contents, especially digital educational material, can transit from one place to another place very easily, okay, quickly. So they are improve the instancy, efficiency, and coverage, cost effect of the education service. Decrease the educational imbalance and increase the variety of the education service. Okay, this is the cloud. Cloud means to support the education, then I can change the contents of the movement. The data is in the education, we need a lot of data. In the AI education, the biggest thing is the data. Nowadays, how to get the data to describe our education procedure. How to use the data to describe our education outcome are difficult. We don't have find the solution. We have some data now is then connected some of them by some sensor, by some log file, this kind of data, and maybe it's the exam results and all this kind of data. And we think this data is not complete for describe our education, the whole entire process. Okay, that is the biggest thing. So we are struggle in the educational data now. Now we talk about another topic is called we need to build up the advanced learning the environment or systems. We need to solve the problem, because to teaching the students to have the ability of the problem solving is the main theme of education, we think. Okay, so we are focused on how to use the AI algorithms to solve the exercise problems. Okay, and this is generally in the paper we call the problem solving. Okay, problem solving is a grand challenge, we think. Okay, because they have meet so many conditions, but maybe it's not all the condition of the 13, but most of them. Okay. What is the problem solve? Means that we have the input of problems, then we have the solver, means the algorithms. Okay. Then we can output the solution. Solution is not just answer, is have provided necessary steps to get our answer and all the inference. Okay, this is the sense, because we want to this algorithm to provide this kind of solution so that we can use this kind of solving algorithm to build up the intelligent system to provide the service for our basic education. That is the purpose. Okay. This kind of things for solve the problems is not new problems. Is old AI problems. After AI, this area is set up in the 1950s, and have some. Since then, they have some researchers work on how to develop algorithms to solve the exercise problems. In the 1970s, they have some progress. This is the one method, is called Wu method. They are to prove the develop algorithms, a method, a system can prove then geometric theorems in the secondary schools, mainly in the secondary schools. This kind. What is their method? Their method is to change, because our geometric problem described by conditions. Okay, the conditions. Even the conclusions is also a claim. All these are the proposition. Okay, the proposition. And their method, Wu's method is translate this kind of proposition into a polynomial equation. Okay, then we can, for given the geometric problems, we can get our systems of the polynomial equations. Then, if this system of equation is then have the final solution, that means this theorem is correct. If we don't have, then means the theorem is not correct in this way. But this way, the Wu's method definitely common people is very difficult to understand. Is the only can prove this theorem is correct or not. Okay, but people cannot understand. It's too complicated. So in this way, because this, the Academy Zhang, Professor Zhang, they have proposed a way to solve this kind of problem by the point elimination method. This method can be understood by human beings, but they only can solve the proof the theorem is they have some figure. They can redraw in this figure. Okay. Also have some research to try to develop algorithm to solve the arithmetic word problems. Okay, this is the some of this example. In the 2014, in 2014, the MIT have a group propose a new method use then machine learning to solve the arithmetic word problems. Okay. There also MIT have some people to work on how to solve this kind of problem is find the shaded areas of a given figure. Okay. All this in the history, they have listed 3 approach of the auto solver. Okay. This we'll explain this later. Okay. Auto solver for the basic education, we have this method. Okay, this is the history. We don't explain detail. Okay. Also, for the arithmetic, have in the very early method is dual frame theorems. Okay, in the 1985. Okay. And most of the method to solve the arithmetic word problem is use the equation set series. Means each given the problems way to understand this problem, to get what it means to understand, to set up a system of equation. And most of the paper, the setup of the equation is linear equations. Then to solve this the equation to find a solution. That is their method. Okay, the generally speaking. Recent years, they have proposed, some researchers have proposed a new way. It's called a sequence to sequence and consider and solving arithmetic word problem as a translation this problem into an answer. Okay, actually, it's not translate the answer. This is just the appearance. Their appearance look like this. Actually, the main thing is translate the sequence of the factor of the given problem into the factor of the arithmetic formula. This formula, after we calculate this formula or express, evaluate this express, we can get the answer of these problems. This is the sequence to sequence means. Okay. In this way, they only can solve the problem have the only one key, one answer. Cannot solve the multi-step problems. Okay. We think that this method they have the problem. So our group work on this method. We propose a new way. We call it relation group series. Okay. What is the difference? Means we are for given any problem is not just limited arithmetic problems. We can math problem, physical problem, chemistry problems. Okay. Then we extract a group of relations, Then we to solve this group to find the solution. The difference is the relations is not just the equations. Can be some equations can the description very close to our problem. That is their benefit. And so in this way, we can summarize the method to solve the problem solving. There are so many methods before us. But all this method, they have some demerit. The main demerit, then the shell demerits is they don't have the method how to find implicit the knowledge to solve this problem. At least for sequence to sequence method, they maybe can find some implicit knowledge, but they don't have explain how to do that. A second main demerit is they cannot solve the problem with the diagram, because in our exercise, even arithmetic problems, they have a lot of problems, have some figures. Without understanding these figures, we cannot solve these problems. Okay, this is two shell. Another delta is the shell demerit is they don't have any way to generate homoloid solution. Okay, so we are proposing our method is called a relation group series. With our series, we can solve this problem. So propose a general principle. We are some kind of a series. We think the problem solving is the equivalent representation transform from one form to another form. Recently, we call this is a state transition theory. Okay, solve the problem is the state transition the series to describe the process of solving given problems. The first state is the given problem. The last state is the produce the solution. Okay, another thing is they have the very bigger state is called problem understanding. After people understand this problem, how to get the solution, there is the problem state understanding is a very critical state transition. On the list, follow this series time. Okay. For this series, we have then proposed a set of the method. Okay, how to get the explicit relations, how to get the implicit relations, how to get the relations from figures. Okay, then all this then get then from these three channels we get the relations. This relation set then we can translate to an equation set, but this equation is not linear equations. Okay, not linear equations, but they have the partial set is a linear. Okay, then we can solve this the linear partial iteratively. Then finally we can solve this the equation set. Okay. How to understand the explicit relations? Okay, how to call is not easy. Use the algorithm, develop algorithm to find the relations. Even explicit relations is very difficult task. Understand this kind of exercise problem. Most of the people think this is we need to semantically understand this the problem. So they are use a lot of the technique from the developed in the NLP. Okay, natural language process, this NLP. But we found that this is the wrong thinking. Why? Because we solved the exercise problem. We may not fully semantically understand this problem. So we propose the Syntactic semantics model to extract the explicit relations. Okay. So we use more syntax, and to replace the semantics understanding. In this way, our model is in the number is smaller and is more stable. Okay, because semantics is unstable. In semantics, each people understand some things in a different way, but syntax is more stable. So we are proposed this the model X-square model method. This is the example. What is this? The key things is what is the syntax? the key thing is what is syntax? Syntax is the change, the pattern of the POS, okay, the path of the speech, POS. Then the PS, then this is the pattern. How this the pattern change in all the problem? It can tell us what kind of relation we need to get from this the problems. So this model, how many this kind of model? In the semantics model, we can get of the thousands of semantics model. But in the syntax S-square model, only just 50 for geometrics. For arithmetic problem is just 100 also. Okay. So with this method, we can understand the geometric problems and physical problems. Okay. This is the way how to understand the physical problem. Okay, even with the fake, with our method. We also develop machine learning method to find out implicit relation. But recently we found this kind of implicit relations is just shallow and implicit relations. We have the more way, we are developing more way to find these implicit relations, like some of the common sense. Okay, we solve some arithmetic problem using the common sense, but this common sense knowledge is not just we cannot use the machine learning to find the common sense the knowledge. Okay, so in this along this is we have published several SCI journal paper. Okay, and currently we have more paper under. We'll have a lot of paper under review laws. Okay. With this, then, problem solve, we can develop advanced learning systems. Like you see, we in the summer group also work on this. The Gaokao robots in China. Gaokao is the college and entrance examination. Okay, Gaokao. Then they have some group work on this. But the other one is some kind of is not a success. Okay. Is in Japan also have a team work on this since Gaokao robots. Okay. Actually, Gaokao robots is the main thing is how to solve the developer argument how to solve the problem in the entrance examination paper. Okay. So we are try to develop technology to solve all the steps of the problem solve. The problem solving involves quite a lot of problem. Okay, like OCR, speech recognition, problem classification, and sentence analysis, problem. Okay, the inference. This is the. So along this direction, in the near future, we'll try to develop, okay, the language-free the software. Currently, we are developing our software in English for English problem and problem in Chinese. Okay, problem in English, problem in Chinese. But in the whole world, we are education technology and sometimes about the 200. We cannot develop this kind of things for each language. That is not efficiency. Whether we can develop a language-free software, that is the question. So with the list of problem software, okay, we can develop a system machine software to solve all the list exercise problem for primary school. Okay. Then with this, then the problem solver, we can develop the system to provide the surface, especially for primary school. Okay. Of course, this kind of surface will need a lot of pedagogies, okay, other things, other integrate a lot other things, but the main thing is problem solve. Okay, problem solve. With the problem solver, we also can do them much easier to develop some the learning diagnosis method, how to evaluate our learning outcome of our students. With this thinking, we have we can develop this kind of surface, the surface to its three-brain robotic systems. Okay, it's because education is a very complicated process. We cannot expect we can develop a robot or system can compete with the human beings. We think that is too ambitious so far. Okay? So we want to develop this kind of systems to help human teacher. Okay? So we suggest we have the three-brain surface system. One is the local brain, another is the cloud brain. Okay, local brain can solve the most of the problems, the same problems. Okay, then if some problem solver needs some very big very huge amount of the computing, then we send this problem to the cloud brain. Okay, they can solve some complicated problem, then just come back the result to our local brain to present. That is the way. Even the cloud brains may not solve all the problems. Okay, so they have some difficulty. Then we can ask our human brain to solve this problem, to give the solution, give the answer. In this way, we can have a very good educational surface system. This is just a practical way to this is the practical system to compare with we ground challenge have proposed goals, advanced learning, advanced personalized learning systems. But in this way, maybe it's the practical way, just the very early version of this advanced personalized learning systems. Okay, we are proposing to develop this kind of system. We have partially developed this system in our faculty. Our small team, the role is to develop the basic, the more fundamental technology. We have very big faculty. They have other groups that develop these kind of systems. This is my presentation. We can then to discuss, okay? Because I just briefly to introduce something to you. Okay.
Thank you very much, Professor Yu, for your presentation. I think we have about 6 minutes for the audiences to ask questions. I have a first question for you.
Okay.
Do you think with the development of AI and platforms and cloud systems and robots, will human beings be ever be replaced by robot teachers or expert systems on the web or any platforms? Do we need human teachers in the future?
Okay, very, very good. This is the further good questions. We think especially for the short term, is cannot be. For the long term, for maybe very many years ago, I don't know where this is happen. But for the years we can expect, we don't think we have this kind of advanced knowledge, advanced technology can do so much, so good. And we develop this kind of technology is to help the teachers. Then the students now, especially in China, each class have about 60 students. 60 students, that is a very normal thing. The teacher cannot monitor all this kind of teaching, can solve all the problem from the students, so many students. So we use the system to help a teacher to teach better than before. That is our purpose. It's not for the replace the human teachers. That is our current thinking. Okay.
Thank you. I think in the chat, if you read the chat, there's a question for you, Professor Yu.
Okay, good.
I will read it.
Okay.
您的 ABCD of educational technology 非常好能解释智能教育。您认为在智能教育下，对我们的教育者、受教育者主要带来了什么样的变化？
我认为这个 ABCD 这个带来的这个变化的话，我其实我写了一篇中文的文章去阐述这些事情，就是说，它这个 ABCD 每个方向会改变很多东西。A 可以改变我们的这个教学自然，改变我们的这个教师的这个角色的。比如说我们有虚拟的教师，我们以前只有这个人的教师，我们现在有这个 AI 就有虚拟的教师，就是这个丰富了。这个 AI 还可以是说它产生一些很智能的这样的一些教学系统，使得我们的教学方法这个变得丰富了。然后它的 AI 会产生这个 virtual 的这些自然 virtual 的空间，就是说我们说的这一个虚拟空间就是虚拟这个 virtual reality 的东西 virtual reality 这样的一些事情的话，使得我们的教学内容教学空间变得丰富了，这就是它的变化。Blockchain 主要的是未来就是用来这一个让我们的这个教学的这样的一个系统的这样的一些知识保护，使得我们的这一个产业更加健康，使得我们内容更加健康。这 Blockchain 主要是这样一个作用。Cloud 就是说它的作用就是我们有产生很多的数字化的教学资源、教学系统，那我们要通过这个 Cloud 可以送到这一个所有很多的地方，我们才可以把我们先进技术的教育把它传送到这个落后技术，我们 Cloud 这样就使得它很容易、很便宜，就是这样子 Cloud。Data 呢，主要是用来这个精确的这个教育化的精细化。有了这些数据以后，我们知道评估一个学生、评估一个教育，我们就可以以数据来说话，更精确、更容易、更及时的找到学习过程当中的 difficulty and challenge and the solution。这就是我们的4个方面，就是改变我们这个教育的4个技术如何改变我们的教育的大概的一个说法。
Another question is, what should I focus on if I want to understand computer vision in sports?
Okay. Sports use the computer vision to analyze the sports video or sports scenes. That is a research for many years. 20 years ago, I work on these areas actually. So there is a computer vision to for sports. They have 2 ways. One thing is that for analyze the sports video. Another one is the use the computer vision to monitor to analyze the live sports, means in on-site to analyze the sports. This way, I think is very good directions. Okay, good directions, especially for 3D TV. We have 3D TV, but we don't have so much 3D program. And the sports can be the main areas to build up the 3D TV program, because we can set up a lot of the things, a set of the camera on the sports the ground. Then we can build up the 3D program instantly, then to broadcast the 3D sports video. Okay, this is the very big direction, I think. Because when we are working on this the sports video analysis, the target is this. But later, several years later, I have changed the research, the institute, so I stopped this. I think this is a very big, very good research direction. That is my understanding. Okay.
Thank you. There are so many questions for you.
Okay, I can read. And what it takes to learn from the scratch? Learning what? Okay. I think it's learning how to do research in the education technology, these areas. I think how to start to do this kind of things. I think first things, start point is you like education. You have the you want to invest your time and to do kind of things. This is a very big good things. You have to start. This is a lot much difficult. It's learning the computer science, the basic we can start. Most of the things where I use them information technology. All these kind of things need information technology to build up the systems. And for the other things, for the sensor, how to collect the data, that kind of things, that we have other areas to develop. We don't worry about that. We just use the information technology to develop the education technology. That is the main things, main thinking. Okay. 下一个阶段，个性化学习的发展方向是什么？个性化学习 the personalized learning, that is the main things. I just actually mentioned this. That is the data, how to define data and collect the data to describe the learning process. That is the key things. If we can have a good way to use data to describe our learning or education process, then we can develop a lot of technology. Okay. Nowadays is the data is not complete. Okay. Only some the log file and some the examination the results. This kind is not enough for our algorithm to correctly understand the learning process. The last question is my question is, may I know what is the role of the instructor and students in the model ABCD learning equipment as negative effect of the multitasking in computer-assisted learning in the recent research? And since we have the negative because we can have this kind of things, have this kind of systems. The people maybe is not in the real physical world. They are less time in the physical world. There are a lot of things in the virtual world. That is negative. So we encourage the students to go to the real physical world to do activities. Otherwise, the students are always emerging in the virtual world. They are consider the things in the virtual world is correct, is the truth. That is the side effect. It's not a good things. Okay. I think I almost answered the questions.
Thank you very
Thank
much.
you for your interest in
Professor Yu. Yes. Excellent. Thank you very much. Thank you.